So in today's, so in this video, we're just going to cover lecture topic number 47. So we defined equilibrium at the start of this chapter as being the resultant as being defined as the resultant force, which is going to be defined as the sum of all the forces acting on a rigid body is equal to 0, and if our resultant moment about any point on the rigid body, which is equal to the sum of all their moments about that point, plus the sum of any couple moments that are applied to the rigid body. If that is equal to 0, the rigid body is at equilibrium. All right. So, what this means, if you write it in Cartesian form, is that our resultant force vector has no component in the x, y, or z direction, and our resultant moment would also have no component in the x, the y, and the z direction. Right? So we can write these two vector equations in their scalar form. So for our resultant forces, we can rewrite this as three scalar equations. We can write it as being a body in equilibrium, the sum of all the x components being applied to the system, due to all the forces in the system must be 0. The sum of all the y components applied to the system must be 0, and the sum of all the z components must be equal to 0. Right? And then for our moment equation, we can also break that into three additional equations, which would state that the sum of all the moments about the x-axis must be equal to 0, the sum of all the y moments must be equal to 0, and the sum of all the z moments must be equal to 0. So from this, we can say that at most 6 unknown forces or moments may be determined using these equations. All right.